This week we'll be studying joints for Chapter 9. Joints are classified into 4 types: bony, fibrous, cartilaginous, and synovial. We'll be spending more time on synovial than anywhere else, but it's pretty straightforward. And so technically a joint, can sometimes be called an articulation, is any point where 2 bones meet. And that doesn't mean that the bone is moving. We usually think about joints as movable, but it's called a joint whether or not the bones are movable at that spot. The name of the joint is usually coming from the names of the bones involved. So it's usually those 2 bones, kind of parts of their names, like radio-ulnar joint is the radius and the ulna. And they're classified by how the bones are bound together. So between those different categories, we see differences in how freely the bones can move based on how they are bound to each other. So 4 categories. Again, I think the first one is a little weird that it's a whole category in this book. It's not in other resources that I've used. But bony, fibrous, cartilaginous, and synovial. So bony joints, synostis, is an immovable joint, and that is not only an immovable joint, we'll see those later, but it's a bone, 2 bones that where they meet, the bones ossify, which means to make a bone. So they eventually fuse together to make a single bone. Some examples where we see this in the body: in infants, the frontal and mandibular bones, and then in elderly, we see the cranial sutures finally fuse together, and the first rib and the sternum. These can occur in either fibrous or cartilaginous joints, but to be honest, I usually am used to saying that there's 3 categories and not include bony joints as one of those 3. So if you feel like you never hear me talk about this again, that's why. So fibrous joints, synarthrosis, is a point where the bones are bound by collagen fibers. Those fibers come out of one bone, cross the space between the bones, and then penetrate into the other bone. So there's 3 different types of fibrous joints: sutures, gomphosis, and syndesmosis. And so these names are kind of hard. They're kind of weird. I mean, I'm sure you're used to all of this anatomy lingo by now, but I can usually remember by thinking about what the joint is, where it fits into which category. So sutures are easy. They're immovable or slightly movable fibrous joints, and we see them in the bones of the skull. And so they can be 3 different types, and we'll see on the next slide some pictures of each one. They can be interlocking wavy lines, and those are called a serrate suture. They can be overlapping beveled edges, and that's called a lap suture. And then they can be straight, non-overlapping edges, and that's called a plane suture. But they're all in the skull, in between the bones of the skull. So there's a picture of each type, and sutures are within the category of fibrous. So it is collagen fibers that are reaching across that boundary and connecting those bones together. Another example of a fibrous joint is a gomphosis. And this is where the tooth is attached to its socket. Again, it's fibrous connective tissue. Technically, it's a periodontal ligament, but still, it's a collagen fiber that attaches the tooth to the jawbone. And then the last type is syndesmosis, and that's a fibrous joint where the 2 bones have a longer collagen fiber, and we see this in the interosseous membrane. The most movable ones, the radius and ulna, and then the least movable example is in between the tibia and fibula. So our next category are cartilaginous joints. The 2 bones are linked by cartilage, and there's 2 types of these: synchondrosis and symphysis. Synchondrosis are bones that are bound by hyaline cartilage, and we see this in a temporary joint at the epiphyseal plate in children, which you learned about in the previous chapter. And then it also is how the first rib is attached to the sternum. So those are 2 examples of cartilaginous joints that are specifically bound by hyaline cartilage. And then a symphysis is a cartilaginous joint that is bound by fibrocartilage. And we see this in the pubic symphysis, which is how the right and left pubic bones are joined by the interpubic disc. And we also see these types of joints in between the vertebrae and the intervertebral discs. So synovial joints is our last category, and it's where we're going to spend most of our time this chapter. A synovial joint is where two bones are separated by a space called a joint cavity. It's our most familiar type of joint, and it's most of these synovial joints are freely movable. It's pretty complicated as far as it is more difficult. There's more parts, more things to label on this type of joint than the others, and it is the most likely to develop a painful dysfunction. So these are the most important joints for physical therapists, occupational therapists, coaches, trainers, that kind of thing, to be familiar with, because they do lend themselves to injury. Their mobility makes them important for quality of life. I want to take a look at this picture just for a second, because on the next slide, we're going to look at some of these features. And so if you see, we've got our two bones, and this is specifically in the hand, so two phalanges. And it shows the articular cartilage at the end of each bone. You should be familiar with this because we talked about articular cartilage is at the end, covering the end of the long bones. And then here we see a joint cavity in between them. This joint cavity is going to have synovial fluid, and it is kind of all held together by a fibrous capsule, and that is together with a membrane is called the joint capsule. So let's take a look closer at each of those parts. The articular cartilage is a hyaline cartilage. It covers the facing surfaces of the two bones. We said that it covers the end of the long bones. It can be 2 to 3 millimeters thick. And so in between, we see a joint cavity. I'm going to call it a joint cavity, not an articular cavity. And then within the joint cavity is synovial fluid. It's a slippery lubricant. It has albumin and acid inside, which gives it a viscous, slippery texture similar to raw egg whites. This synovial fluid nourishes the cartilage and removes the waste, but more importantly, it makes the movement of the joint almost friction-free. And we see a joint capsule that is connective tissue that encloses the cavity and keeps the fluid inside. So the fibrous capsule is continuous with the periosteum of the adjoining bones, and then we have a synovial membrane that is secreting the synovial fluid. In a few synovial joints, fibrocartilage grows inward from the joint capsule. This is going to form an articular disc, a pad between the bones that crosses the entire joint capsule, and it lists the examples of some synovial joints where we see this. And then you can see a meniscus in the knee. We have two cartilages extend inward from the left and the right, but they don't entirely cross the joint. Those cartilages help absorb the shock and pressure of our movements and then guide the bones across each other. We also, on some pictures, will see accessory structures that are associated with synovial joints. A tendon is connective tissue that attaches muscle to bone. A ligament is similar, but is attaching one bone to another. We're going to specifically take a closer look at the knee joint and how many ligaments there are. You might find a bursa, which is a fibrous sac filled with synovial fluid. It's located between the adjacent muscles where the tendon passes over the bone or between the bone and the skin. And then sometimes we see tendon sheaths, which are long cylinder-like bursa that are wrapped around a tendon. And we see these in the hand and the foot. And so this is showing you what we mean by the tendon sheath and the bursa. There's kind of a lot going on here, but if you look at the middle finger, it shows the tendon sheath and what that looks like opened up. And then the other finger shows the tendon sheath not opened. Book talks a little bit about exercise and articular cartilage, kind of the benefits of exercise. So it warms the synovial fluid, so less viscous and more easily absorbed by the articular cartilage. And so when the cartilage swells, it is making a better cushion against the compression. And so if we have a warm-up time before exercise, it helps protect the cartilage from wear and tear. And then if we have repetitive compression of the cartilage during exercise, it squeezes the fluid and waste out of the cartilage. And when the weight is removed, the cartilage absorbs the synovial fluid like a sponge, and that gives it oxygen and nutrients. Without exercise, the cartilage can deteriorate more rapidly based upon inadequate nutrition and waste removal.